Hello everyone, welcome back to the channel. And today we are with problem 3345, that is the smallest divisible digit product 1. So, what this problem states is basically you have to just divide two numbers, but there is a simple twist that you do not have to divide directly the n by t, but you have to find the product of the all the digits of n and then divide it with t. If it is divisible, return the value of n. If it is not, increment the value of n and check this back until you find up that the product of the digits of n is directly or it is directly divisible by t and it do not leaves any reminder. So this is the whole problem, and these are the two examples. I will explain you about these examples here. So considering this as an example, here n is equal to 10. So what happens is basically when n, the value of n becomes 10 and t is equal to 2. First, what we have to do, we have to find the product. So what will be the product? That is 1 into 0. That will basically return us 0. Now, as we know, the product is 0 and 0 is divisible by every number. So, whatever the value of t, 0 will be divisible. So, as 0 is divisible, you have to return the value as it is. That is the value of n. This is an simple case. In the second case, we have n is equal to 15. First, find the product of the digits. The product becomes 1 into 5. That will return us 5. Now, when we divide 5 by 3, the value will be 1.67 approximately. Now, we have to find an exact divisor, so we cannot move with this. What we do is we take an next number, that is 16. The product of 16 becomes 1 into 6 becomes 6. Now, when we divide 6 with 3, or let's say take the modulus operation, this gives us 0. Now, as 0 is the remainder, the number directly or properly divides the whole number or the product of the digits. So here we have to return output becomes 16. This is the simple case of what the question states. Now moving back, this is the logic where you can implement this logic and solve the question. I have to tell you two more cases where it shows your problem understanding, so that will help you better understand the problems from next time. So in the case one, let's move to the question. I will show you here constraints. In the constraints part, what has is the value of t is between 1 to 10. So if the divisor is between 1 to 10, so that basically means that you will be having, or after every 10 numbers, the number will be divisible by t. You might think that this is the case. So after every 10 numbers, that if we take the maximum value of t's as 10, so 70 comma 80. So you will say that after these two, in between these two numbers, we can find, or these number will be divisible. But remember, in the question we do not divide directly n, we divide its product of digits. So we cannot guarantee that it will fall in the definite range. So this particular case might partially be applicable in some cases, but this is not the perfect case. Now I will tell you one second thing. See, the value of n is between 1 to 100. So the if considering the value of n is between 1 to 100, now in this range, that is in 1 to 100, there is an obvious thing that in any 10 digits sequentially, in any continuous 10 digits we say, there will be at least one number where the it will have at least one zero in the digits. Let's pick a random range. Let's pick 46 comma 56. let's consider this case. I have picked this randomly. So the in this particular range, there will be a number 50 where it has at least one zero. And whenever there is at least one zero is present in the number n, what happens? The whole product becomes zero. And when the product is zero, zero is divisible by any number. So the loop, when you will increase the value of n, like in this case we have increased the value from 15 to 16 and checked it back. So here that was a lucky case that we have found the answer. But if not, what will happen is we have to move back and we will be increasing the value. So I just want to explain you this case so that you will not definitely go on increasing the value of n to infinite, because you will get your solution in a maximum of 9 to 10 steps where you increase the value of n. So this was the whole intuition. I assume that you understand it better. Now let's move to the code part. So this was the whole understanding of the problem. Looking at the code, this is the main function, and this is the function I have implemented. What this function basically does is it just returns the product of the digits, nothing more. And what have to do is, like, here we have product is equal to 1. So whenever we have to find the product, we initialize it with 1, because whenever we multiply anything with 1, it will take the value of that particular number. So whenever it is multiplied with any number n, let's say, it will take the value of n. But if I have initialized product with 0, and if it was multiplied by n, it will definitely return 0. So never initialize product with 0, initialize products with 1. This is the first case. And talking about one more thing, that is in sum. Whenever you are calculating sum of anything, initialize it with 0, because 0 plus n returns n. And if we initialize it with 1, 1 plus n will return you n plus 1. So this is the like the whole part, which this is a small concept everyone knows. Just I thought if it might be someone, a beginner who do not have the exact knowledge, this will help them to understand. So this is the product where taking initialize it with 1 and then picking the one by one digits at the unit place, and then like dividing the numbers, so that this is the whole logic, so that we find the product of the digits. And whenever we found the whole like product or the number, we return simply the product. So this is simple. Now here we have initialized int product, that is a number. So here I guess there is no need of int product 2. Just pick this particular number, while digit product of n, like I have used the int product where I have to store this, but as I have optimized the solution later, there was no need of digit product, so I have removed. So not digit product, but the product, int product. So the digit product of n, if it is directly if the modulo of t is not equal to 0, that what that means, like in this particular case where the like 15, it was 15, and when we modulo its product, that we got 5, and when we did 5 modulo 3, that was not equal to 0. So in this case what we have to do, we have to just simply n plus plus, that is increase the value of n. So we move from 15 to we move to 16. So when we move 16, this loop we will find the digit product. So this will provide us 6. Then we have modulo 3. Now once that becomes 0, we have to exit from this particular loop and we move out. Now what is out? Return n. So what we have done, we have found this, we have got that it is like perfectly divisible. Return the value of n, that is 16. So this is the case. This is the simple logic behind the question, and I hope you understand this particular question. I have to just show you how fast this code is, and it beats 100% of the lead coders. So this is like an optimum solution where it has passed 1000 out of 1000 test cases too. So that was about today's video, guys. I hope you liked the solution and the understanding. I am like improving the pattern or the method with which I explain. Like today I have introduced this particular board where I have explained things. Just ignore the handwriting because I am been operating it with mouse, so it becomes somewhat difficult, but that's it. So I hope you understand the code intuition, look at the